Thank you for inviting me to have a chance to present Korea's quantum standardization ecosystem. So, good morning, everyone. My name is Dae-hyuk. I'm director of Korea Joint Quantum Institute, Next Quantum, and the institute is under KRISS, Korea Research Institute of Standards and Science. This institute is a national metrology institute. And all the countries in the world should have at least one national metrology institute. So I would like to start my presentation. Okay, so I'd like to start with IEC ISO JTC3, Joint Technical Committee 3 for Quantum Technology. Korea's involvement in quantum standardization began well before the formal establishment of JTC3. In 2021, Korea led the development of the IEC white paper on quantum information technology. More than 40 experts worked together for approximately 1.5 years. This white paper helped identify the future need for international standards across quantum computing, communication, sensing, and enabling technologies. In 2022, IEC established SEG-14, Standardization Evaluation Group, and Korea played a leading role in its roadmap activities. In 2023, Korea launched the National Quantum Technology Standardization Forum to coordinate domestic experts and prepare for international standardization proposals. And these efforts contributed directly to the establishment of IEC ISO JTC3 in 2024. And Korea was selected as the inaugural chair country and hosted the first plenary meeting in Seoul. By 2025, Korean preliminary work items in quantum sensing had already been approved. This demonstrates that Korea's leadership was not only institutional but also technically substantive. And today, Korea continues to contribute at both the governance and technical levels. The chair of JTC3 is Mr. Hae-sung Lee from Korea, and the structure has also expanded significantly. It now includes a joint subcommittee on quantum computing and, it has now working groups covering terminology, quantum sensors, supply chains, benchmarking, and so on. So Korea has a particularly important role in Working Group 10 on quantum sensors. Mr. Jun-sik Park serves as the convener, providing leadership in defining the scope, priorities, and project pipeline for quantum sensor standardization. JTC3 Working Group 10 now involves 23 countries and 104 experts and 5 more parallel items for the standardization. And quantum sensing is moving from laboratory demonstrations toward industrial and public sector applications. So the standards will be needed to ensure that performance claims are comparable, repeatable, and trustworthy across countries and technology platforms. This slide shows several concrete standardization items currently led or co-led by Korean experts. The first is undetected photon quantum spectroscopy, led by KRISS. This technology enables spectroscopy using photons that do not directly interact with the detector, creating new opportunities in wavelengths where conventional detectors may be limited. The second item concerns cold atom free-fall absolute gravimeters. KRISS is serving as a co-project leader. This work aims to establish requirements and methods for absolute gravity measurements based on atomic interferometry. Third item is quantum detector tomography, led by KRISS. This addresses the characterization of quantum detectors and provides a systematic method for understanding detector response. Finally, Korea is co-leading a technical report on the overview and framework of quantum sensors. Korea's quantum standardization ecosystem is built around interaction among several groups. The Ministry of Science and ICT, MSIT, provides national quantum policy, R&D funding, talent programs, and ecosystem development. Korean Agency for Technology and Standardization, KATS, serves as the National Standards Authority and coordinates Korea's position in IEC and ISO. And KRISS provides measurement foundation, traceability, performance metrics, evaluation methods, test beds, and so on. Government-funded research institutes, including KRISS, KIST, ETRI, and KIST, develop quantum core technologies and enabling components. And also, industry organizations and companies contribute use cases, interoperability requirements, supply chain needs, and so on. Yeah. Academia develops new technologies, trains specialists, and supports international research networks. The core function of this ecosystem is translation. National R&D results and market needs must be translated into prioritized and technically credible international standardization. This translation process is what allows sound scientific innovation to become industrial infrastructure. This slide outlines the evolution of a national quantum policy of Korea. In November 2024, the Act on the Promotion of Quantum Science and Technology and Quantum Industry was enforced. And in March 2025, government deployed the Quantum Initiative Promotion Strategy to keep quantum initiative moving forward. And at the beginning of 2026, they announced the Quantum Comprehensive Plan, which is a master plan to promote quantum science, technology, and industry. At the bottom of the page, you can see the increase of government's budget for quantum science and technology. The 2026 government budget for quantum consists of 61% of R&D, 20% of infrastructure and ecosystem, and 19% of global cooperation and talents. The Korean government has been investing in quantum science and technology. The compound annual growth rate has reached 60% for the past 7 years. Especially comparing to 2025, the government raised about 41.6% more in 2026. In January 2026, unveiling the Quantum Comprehensive Plan, the government announced its vision and strategies for quantum sector. This vision is Korea leading next AI with quantum technology. Based on the vision, they defined 3 domain strategies and 4 foundational strategies. This master plan for quantum is going to accelerate the development of quantum science and technology and quantum industry in Korea. And this slide illustrates the breadth of Korea's quantum ecosystem. The MSIT connects R&D funding agencies, government research institutes and universities, quantum fab facilities, academic societies, industry, workforce programs, and international cooperation centers. Korean organizations are active across all 3 major quantum domains. In quantum computing, Korea has already demonstrated 20-qubit systems and is pursuing larger scale platforms. So you can see here that 300 qubit with a quantum error correction by 2032. In quantum communication, Korea has demonstrated long-distance quantum information transmission and has accumulated significant industrial experience in quantum cryptography. In quantum sensing, Korea has developed highly sensitive quantum gravimeters and other advanced sensor platforms. This ecosystem matters for standardization because standards require input from the entire value chain. Researchers who understand the physics, companies that understand deployment, users who define requirements, and methodology institutes that can verify performance. A broad ecosystem therefore provides Korea with a strong foundation for identifying credible international standardization topics. Korea is now placing greater emphasis on industrialization. The government is considering region-specific quantum clusters that connect research capabilities with the local industries. Potential areas include quantum computing, sensing, communication, and enabling materials, equipment, and quantum algorithms. The strategy also includes attracting global quantum companies and supporting domestic companies through tailored incentives, infrastructure, and collaboration opportunities. Another important element is full cycle support. Companies need access to core infrastructure during technology development, proof of concept support during demonstration, and assistance with the commercialization and global expansion. Standards are essential throughout this process. At the development stage, they help define performance metrics. At the demonstration stage, they support the testing and interoperability. At the commercialization stage, they provide confidence to buyers, investors, and regulators. Therefore, industrialization policy and standardization policy should progress together. Industry organizations provide the interface between market needs and formal standardization. The Korea Quantum Industry Association, or KQIA, began with 32 founding companies and has expanded to more than 100 members. Its membership includes hardware, software, cloud service, startup, and user companies. KQI has aggregate industrial requirements, identify supply chain challenges, and communicate commercialization needs to government and standards bodies. The Future Quantum Convergence Forum, or FQCF, has a broader network involving companies, public institutions, research institutes, academia, local governments, and international participants. Its role is particularly important in building consensus, identifying use cases, and incubating pre-standardization topics. The process shown at the bottom summarizes the industry contribution, capture market demand, and build consensus, generate technical evidence through pilots and benchmarking, and then submit mature inputs to standardization bodies. Industry associations are therefore not simply networking organizations. They are operational interface for converting market demands into standards outcomes. KRISS is Korean National Metrology Institute, and the role of National Metrology Institute is especially important in emerging technologies. Before a product can be certified or standardized, its performance must be measured reliably. This slide highlights how KRISS has applied quantum science to national measurement standards and industrial services over the past 3 decades. I will not go into details. So this example shows that KRISS has a long experience in transforming quantum phenomena into reliable measurement system. So this experience provides the foundation for the next stage, moving from quantum for metrology to metrology for quantum. where KRISS supports the evaluation and standardization of emerging quantum technologies. And this slide presents KRISS as a pre-standardization platform covering all major quantum domains. In quantum, companies can bring components or systems to KRISS, evaluate performance under controlled conditions, compare results with the reference methods, and generate the evidence required for standards. This creates a practical bridge between scientific research and formal standardization. And this slide provides an example of how a testbed can support industry. So WeTheWave is a Korean company that develops high-frequency and cryogenic connectivity components, including connectors, cable assemblies, and so on. So KRISS is developing superconducting quantum computer, and KRISS and the company can share the profit by using our facility as a test bed. Finally, quantum standardization must be international from the beginning. KRISS is developing a global pre-standardization network through cooperation with the leading national metrology institutes, universities, research organizations, and companies. NMIQ provides an important platform for coordination among national metrology institutes working in quantum technology. So KRISS will also join to these activities for the future global standardization. Thank you for your kind attendance.
Thank you so much. It's an honor to be here and to share some thoughts with you today. So what I thought I'd do before I just jump into what the US does in this space is go through a little level setting Standards 101 talk. So first of all, yes, standards actually make a difference, so it's worth all the attention that we're giving them. And standards come in a lot of flavors. They mean a lot of things to different people. So I come from a metrology institute, the National Institute of Standards and Technology, and we care a lot about this upper physical standards and measurement protocols. But I think when most people hear the word standard, they're thinking more about interoperability standards and interconnect standards, to know that if you buy a product, it's going to fit together with the other products in your systems. But you can also standardize, and people do many different things: use cases, certification, test protocols, terminology, procurement standards, spec sheets form a kind of standard. So not only do they mean a lot of things to a lot of people, but they are also developed in many different ways. So I like to think of standards with the big S. These are the formal national or international standards developed by organizations like ISO and IEC. But there's also standards that are produced by other organizations. So you could think of these as standards with a little s, right? They're set by other groups like consortia of industry that come together around a common purpose, open source development, or sometimes it's just that a single company comes up with a really great idea and everybody wants to use it. And an example of that might be PDF, being produced by Adobe, which has since been submitted for formal standardization, but it started out as a de facto standard. And then there are standards near and dear to the heart of a metrologist. These could be thought of as standards with the capital P for physical standards, which sort of cement measurement procedures and practices. And all of these different ways of creating standards come with different rules, different ways that they're produced, different access requirements, different voting privileges. They're made in different time frames. Nobody ever thinks these happen very quickly. And you might like to think that there's somebody orchestrating this across the broad world of standards, but actually there's nobody in charge. There's nothing stopping any group of you from getting together with your best friends, calling yourself a standard-setting organization, and creating one. So when they work, They are very impactful. They create a common language for researchers to talk to industry, to talk to buyers. They can create fair and open plug-and-play markets, like I said, so that things can click together, so companies can focus on where they innovate and not have to worry about how they fit into a broader ecosystem. They can spur innovation, and they can create business opportunities by things like standard essential patents. But when they don't work, they can actually do more damage than good. They can contradict all those great benefits that we're looking for by giving unfair advantages to the company or organization with the loudest voice at the standard setting table. They can create barriers to trade. They can stifle innovation. They can entrench poor technologies. And they can impede the interoperability that we're all looking for. So standards support every stage of the technology development life cycle. So this is just one take at the technology life cycle, from inventing a new idea, doing the R&D that supports that, to de-risking those new prototype approaches, and validate them, find use cases for them, until you're eventually convinced this is something that's marketable, and you dive into product development, marketing, supplying, supporting, and then you have the whole robust cycle of supporting that product in the field, and then finally you want to learn something about how that product gets used in the field. So every stage of that life cycle can be supported by standards. If all you wanted to do was really great science in your own lab, you don't need standards because you're controlling every stage of that process. But if you're trying to build a market, then standards are essential. So even early on in the invention stage, you can have terminology standards, and you still need test and measurement standards, right? Because you want to start building those bridges to speak a common language. And the test, measurement, characterization, and performance, this all helps you build your own technology, take that next step in the innovation cycle, and then start to de-risk the technology as it evolves. Metrics and benchmarking, this is a very important step, so important that when the Quantum Economic Development Consortium kicked off in the US, the very first conversation at the very first meeting was about benchmarks and metrics, because end users want to be able to sort fact from fiction and pull, sort the hype away from actual performance. And then, as I said, I think the interface and interconnect standards, that's what most people think of when they think of standards. But then as products mature, you want to help provide user confidence by things like certification test programs. And then finally, you want to be able to learn from the experience of products out in the field for sort of that industry 4.0 scenario, and feed that information back into the development of the next generation of product. So just to move a little bit towards what's going on in the world of quantum standards, first, just to paint the picture, technology readiness levels only take you up to the point where technology has been proven in the environment for which it's intended. And then there's a whole nother stage that happens after that of market development. And so quantum technologies, this is an imperfect representation of where everything is. I'm always happy to hear people tell me, move this one up a little or this one back a little. I even had an annealing company say, hey, we're not as mature as you think, so put us earlier. But this just shows you the technologies in quantum are really across the board. And that there are standards efforts spread out across those technologies and across those life cycle stages. But a very important development that happened about 2 years ago was the establishment of, it should say IEC, ISO, forgive me, hey song. But it's a Joint Technical Committee 3, the first international joint committee between these two major standards organizations focus exclusively on the development of quantum standards. This is very important because it gives us an international focal point for the entire community to come together. And so another question we ask is, when do we know it's the right time to produce a standard? Because as I pointed out, there's a lot of hazards in doing this at the wrong time or in the wrong way. So we're developing a concept called standardization readiness levels. I've been working on this for the last 4 years, whatever, at my home base at NIST, in the Quantum Economic Development Consortium, and now we've started a new task force within the Joint Technical Committee 3 to fine-tune this and make it useful and practical and pragmatic. But there are 3 basic areas of consideration. You have to ask, is the market ready? Are there companies providing products into this market? Are there use cases? Do test beds exist? Is the technology ready? It's not just a question of, are you at TRL, whatever. It's also, does the metrology exist to support the technology? Are adjacent standards available and adjacent technologies? And then finally, are there a community of experts ready and willing to develop the standard and a community of users ready to adopt it? So you put all this together and you can create a standardization strategy that we're calling standardization readiness levels. And stay tuned, because in the next year, I hope that through our efforts within JTC3, we have something to publish and share. And finally, standards take time to grow. It's not just you go, oh, we need a standard, and it pops out at the other end. First, you have to have something, some technology that's worthy of standardization because it has the potential to form a market. You want pre-standardization. This is, as I'm going to mention, what the focus of NMIQ is, which Dai-Hyuk alluded to, doing that sound measurement science to make sure we know how to measure and characterize technologies. You would develop a number of competing specifications, and finally an organization like IEC and ISO could come along and pick one of those options and make it a formal standard. So with that, I'm going to transition to some highlights from the US standards ecosystem. So first, a few years back, the US published a standards policy for critical and emerging technologies. And what I love about this policy is it calls for investment in pre-standardization research, that very important foundational work that's needed to make good standards. And it encourages US companies to participate, workforce development, and then to do this in an inclusive and whole environment. So, as I mentioned, this pre-standardization work being so important, NMIQ is a new collaboration among metrology institutes with the steering committee formed by the G7 countries and Australia. We created a memorandum of understanding that was gleefully signed in France last October, and Tim Pryor and I are co-chairing it along with our very dedicated colleagues from all 8 countries. So the mission of NMIQ is to, oops, this is not NMIQ, sorry. Now I'm back to US. Forgot I was flipping through this rather quickly. But the mission of NMIQ, let me just say, is to accelerate the development and adoption of quantum technologies by creating these sound measurement practices. So in the US, we also launched this advanced Center of Excellence, you could call it, for for standardization in critical and emerging technologies. So its intent is to broaden US stakeholder engagement in standards. It's very expensive to play in the standard sandbox. Typically, it takes a dedicated person that does nothing but standardization. Not every company can afford that. And so we're looking for creative ways to broaden the tent and make it easier and more accessible for companies to engage. And the US, of course, like most countries, it's industry-driven participation. The government is not pushing standards. It's got to come from that bottom up. So anyway, this new center is developing tools, data sharing platforms, so just to help facilitate engagement and training the next generation. Then just a word about what is NIST doing in the world of standards. So I know standards is our middle name, but we are not a standard setting organization, typically. Although one area that we've definitely taken initiative, and you might think that makes us standard setting, is post-quantum cryptography. I love this story because it was started by one of our staff members who, together with a half of a postdoc, right, decided, boy, this is going to be important, we better start something. And now it's become this worldwide effort, and we ran competitions to develop algorithms that would stand up to the threats of quantum computing. And as we've heard, there are many people mentioning PQC in their talks throughout this conference. And then I've already talked about NMIQ, but NIST in general, we engage in standards development because we have such deep expertise in so many fields. We bring that to the standards table. We use our basic research to do fundamental measurements that then can be fed again into standardization, and we also interface with many organizations, including IMECO, which is running a special session this afternoon in the building. I think it's entrance D, forgive me, it's on the flyer on your chair, and I hope many of you will decide to join us. So NIST also stood up the Quantum Economic Development Consortium, which is an industry consortium, but we bootstrapped it for them, and we still invest in them, and they are now over 250 members, and I think have set a model for the world in terms of industry quantum collaborations. So in sum, I'd just like to say that standards fuel every aspect of the technology lifecycle. The best standards are based on sound science and address real industry needs. IEC ISO JTC3 is our international focal point, and NMIQ is an exciting new collaboration where we're tackling that pre-standardization work. So thank you so much for your consideration.
Thank you very much. I've learned a very good lesson this morning that I'd like to share the presentation with. Do not go for a 40-minute run in Korean humidity because you will start sweating like crazy. So if I'm sweating badly, I can only apologize to our colleagues in the room. A little bit about the NPL sort of program, because effectively we wanted to just shift the dial a little bit, because I'm conscious that you've heard a lot about standardization. So what I wanted to do is just say a few words about NPL and its history and why standardization is so important to the work that we do. Effectively, NPL has got 126 years of history, so we are a very historical organization, and at the heart of that has been standardization and activity. I think the key thing that I want to leave you with on this slide is the fact that NPL is a fully independent and impartial organization. So we're technology agnostic. We don't care if your computer is from a certain company. What we care about is the right answer. As a program, and I think this is really important just to say, because I'm conscious there's a lot of sort of overlaps with other presentations, the NPL activity really stems from the fact that we're a multidisciplinary organization. So when we talk about standards, we're not talking just about quantum as an organization. We work across national timing and predominantly in the telco area as well. So if we look at some of the things that are happening globally when it comes to interoperability and telecoms, the reality is we've realized that in the UK we need to set up test marks, benchmarks, and various standardization platforms to make sure that we're doing proper 5G, 6G penetration testing, to make sure that our environments are secure and fit for purpose. And one of the things I like to always say is the fact that we've come from the UK and we've flown to the Republic of Korea, and I can use my mobile phone, is a testament to how important international standards and cooperation are. And if you look at the value of that to global economies, don't quote me on this, maybe quote me on this, but do check and do your own homework. But it's between $4 to $6 trillion. You know, that's the level we're talking about. And there's no reason why quantum can't get to that view. In the UK, we are taking standards very, very seriously across our 5 critical technology areas: artificial intelligence, quantum technologies, future comms, semiconductors, and EngBio. These are the areas that the UK is predominantly investing in. I know this is a quantum conference, but I think it's really important just to highlight that it's not just quantum that the UK is thinking about when it comes to standardization. And I think as time goes on, the convergence of these technologies becomes more and more important, because actually, what are you going to use a quantum computer for? In effect, you're going to use it to converse with AI and potentially even EngBio and the like. We have a 10-year vision in the UK to be a leading quantum-enabled economy, recognizing globally the importance of quantum tech for the UK's prosperity and security. So the UK has a 10-year vision. So we are here to really say we want to engage, we want to work with the Korean government and industry, and we're really delighted to be here. And it's not just me, I'm surrounded by fantastic colleagues, including Tim Pryor, and we have a wonderful trade association that's led by Jonathan Leigh-Smith, who's here somewhere as well. So a little bit about our past, because I think it's important when I stand up and talk about standards that I acknowledge that it's 126 years we've been doing this. You know, there's real rich history. And, you know, we go back to 1902 when we started this, and actually a lot has changed since 1902, clearly. But actually the heart of the work we do as an organization has remained very, very sort of static. And that's really around metrology, the SI, and having that science and technology endeavor and rigor to provide trust and assurance to industry, academia, and the like. A little bit about the work we do in terms of quantum research. So when we talk about standards, we're talking about standards across some of the key themes in the UK. So we talk about quantum computing. So standards and benchmarking are at the heart of the Procure program that's currently being driven out of the UK. For those of you that heard Josh Feder's presentation yesterday, who's our colleague from the Department of Science, Innovation and Technology, Procure is a £2 billion program to effectively procure a quantum computer on behalf of the UK. And the key to that isn't a particular technology platform at the moment. It isn't a particular country. It's all about using evidence-based decision-making, so science driven by standardization and benchmarks, to procure the right computer for the right application. Barbara said it in her wonderful presentation. The reality is there's a lot of hype at the moment. You know, everyone's procuring computers, everyone's procuring things, not just in computing, but across the quantum ecosystem. How do you have trust that the data that you're getting from those technologies has a sound science and technological rigor? So a lot of the work we realize in terms of the ecosystem in the UK is really around end users. So we really got industry at the heart of the work that we're thinking about, because we realize that actually without industry using the standards to scale and to really drive product into market, some of the standardization thinking will get lost. And that's why we talk about standards, certification, safety and regulation, really at the governance and trust foundations of our program. So the future, where are we going as a quantum ecosystem? Really, the international side, you would have heard many colleagues say it, you know, from many different countries. I've heard US colleagues say it, I've heard Korean colleagues say it. You know, we can't do this alone. It's really important to reiterate that we need to partner. And the world is getting a very difficult place. There's a lot of bad things happening in the world, and it's really important like-minded countries come together, do joint activities, and work with each other to drive forward the benefits of this wonderful new emerging technology. Supply chain, as I said, is important. I've been very lucky this week to have seen some of the best of the Korean supply chain, and what a wonderful job some of your companies are doing to set themselves up for the quantum sort of tech area. And really, you know, we want to be at the heart of that with you. We want to work with you to make sure that the technologies that you're working on have the right standards and are fit for quantum applications. Skills, again, it's something that we say in every presentation, because training and quantum skills, physicists. I have a very dirty secret. I am not a quantum physicist by background. I'm a nuclear person through and through. But quantum, you know, there's a translation, and I think many of us in this room can hopefully acknowledge that you can do different things later on in your career. And of course, standards. I don't want to repeat much of what was said in the first two presentations, but again, working for an NMI, very similar to KRISS and NIST, that ethos, that mindset is very, very similar in terms of our approach. So a little bit about our missions. I'm not going to dwell on this slide, but really it's around that quantum computing that I just want to focus in on. And I'm very happy to speak to some of you after this to circulate some of these slides, because there's nothing uber sensitive in this. But it's really important to talk about the benchmark and verification piece with this and link it up to initiatives like JTC3 and NMIQ and the like. Because actually that trusted test and evaluation principles that we talk about should be replicable across different countries. It's imperative that we share our homework and share our knowledge to make sure that we're all investing in the right areas and making sure that at the heart of that, there's trust and interoperability. And I just want to really focus in on the benchmarking suite piece around the NIST machines through 2035. This has to be done in parallel with industry. So when industry bid into a Korean call or a US call or a UK government program, the answer to the benchmarking question has to be similar. There has to be a standard approach there. Because there's many different things that are going to be happening. So, we're talking about multi-qubit hardware benchmarking, and then potentially, depending on how things go, with networked ion traps for benchmarking of distributed quantum computers, and then having network quantum compute at scale. These will all need standards at the heart of it. I'm not going to dwell on these just because of time constraints, but I just want to say a few words about the work that we're doing in the UK. This is a really interesting picture that was taken about 3-4 months ago, because this is our CEO, me, Lord Patrick Vallance, who's our science minister, and one of our senior scientists. And you can see our CEO with the blue tie there. I thought he was going to fire me after the meeting, because he looks really angry in the picture. But actually, he told me afterwards, well, the reason I'm here is I guess I haven't been fired. He wasn't angry. He was really impressed with what we were saying, because really, Patrick Vallance's first question to us was, okay, which quantum computer should we invest in? And I think even at that level, at that scientific ministerial level, those are the questions that everyone's asking. And we stuck to our lines and said that, it's, in our view, modality, way too early. In our view, it needs to be backed by evidence-based decision-making. And in our view, it needs independent verification to answer that question. Luckily, our science lead said exactly the same thing during the lab tours 10 minutes later. Otherwise, I would have been in a lot of trouble and probably not made it to Korea. The picture on the left is our Institute for Quantum Standards and Technology. So we call it the IQST. And when you come visit London, we are 8 miles from southwest London, from Heathrow Airport in southwest London. We'd be delighted to host as many of you as possible. We have the big quantum showcase that many of you will be familiar with in November. But really, the work that we do in standards and in superconducting qubit technologies and ion trap technologies really happens in that building, as well as a lot of the work we do on clocks, which for those of you that will be familiar, we've been working in quantum as an organization before quantum was cool. We've been working in quantum since the 50s, and birth of the cesium clock and the like. And a lot of that knowledge and a lot of that organizational history is really at the heart of the work we do today. A little bit about the work that we're doing on the Quantum Standards Network. I will take no credit for this. The credit should all be given to Tim Pryor, who's in the audience, who's the program director for the QSN and who's working and driving UK leadership in this area. But this is a really important initiative in the UK. We've just signed the contract with our government owner. And the reason why this is so important is that it brings together the ecosystem. And when I say the ecosystem, I'm not talking just about NMIs. I'm talking about our military organizations. I'm talking about our Secret Service individuals. I'm talking about our NQCC, so the National Quantum Computational Center, and obviously our trade association. This is really around us having a central point to bring standardization and activities together. So if there's more interest on that, please reach out to Tim and I. We'd be delighted to talk to you about that at length. But actually, the military piece is also very, very important. What we're seeing in the UK is we need a joined-up approach between our civil activities and our military activities. It doesn't quite work if you don't have that joined-up approach. And again, I'm not going to say too much more about that up here, but if you wanted to speak in private, we can talk a little bit about that as well, because quantum technologies for military applications are obviously a very significant thing going forward. Barbara mentioned things around cryptography and PQC, but then there's also quantum sensing and other things as well. I'll leave it at that. I just want to say it's been an absolute pleasure to be up here and be able to present in front of you. Thank you so much for hosting. And any questions, please feel free to reach out to me throughout the day. Thank you very much.
Yeah, good morning, everyone. I'm very happy to be here. So my name is Nicolas Spethmann. I'm with Physikalisch-Technische Bundesanstalt, or short PTB, which is the National Metrology Institute of Germany. So I won't say much about this during my talk, but you heard my colleagues from other countries before. So basically the same holds for PTB. We are a very old, more than a century old national institution, and standardization standards and physical standards from Barbara's talk lie at the heart of our work. This is also why we play a role in the quantum technology ecosystem and in standardization. And as you can see, I will show you some examples from Germany, but in particular from Europe. And the reason is that a lot of work we do is already on a European level, as I will show you. So since my colleagues already talked a lot about the basics of standardization and also about the international level, I really want to focus on Europe. And that doesn't mean that the international level isn't important for us. On the contrary, I will come to that at the end. But I would like to give you an impression how we do it on a German and European level and how we connect it. So first of all, I just want to spend a few words how it works in Germany. We have our National Mirror Committee. We have National Standardization Organization, in our case DIN and DKE. And they run the Mirror Committee that, for standardization that was established in 2023. And the chair is my colleague Thomas Gerster, also from PTB, that some of you know, and the co-chair is Valentin Torgler from an industry corporation. We heard already that industry should drive this, and also the standardization principles are very important for a Mirror Committee and committees in general. So standardization should be voluntary, public, and it should involve all interested circles and work on consensus and also reflect the state of the art of science and technology. And in our Mirror Committee, we have about 50 members that reflect that, from academia for state-of-the-art science, metrology, but also from industry, startups, and regulatory bodies to combine all of this. So this is the German Mirror Committee. And as you can see here, this is not complete. It's just a sub-part of standardization organization. I think Barbara very well explained that there are many standardization organizations, and you can see I'm focusing here on the ones that have a national delegation principle. So that's some subset of them. So it means the government has a contract with DIN and DKE, and DIN and DKE represent Germany in international standardization in such standardization organizations. And this is by country. Okay, and as you can see, there's a European level, that's CEN-CENELEC, and then there's obviously also the international level, and we have the chair of JTC3 luckily with us today, Hye Song, and I will come to this later. So those are the different levels in this subset. And I will come back to this in a second. Before I do that, just one more word about the German work on standardization. So we have something that we call a strategy forum. So this is run or was founded by our government, by our state secretary from the Federal Ministry of Economic Affairs and Energy, which is also our home ministry in some sense for PTB. And the idea here is to bring again together senior representatives from business, association, academia, standardization, administration, and society. And as Cyrus said before me, this is not only about quantum, it's about topics that are becoming very important nowadays. And in this case, it's hydrogen, circular economy, AI, data, others, but also quantum technology. And in this forum, there's strategy discussion how Germany should align itself in this standardization development. This is mirrored by a European high-level forum, which is basically doing the same thing, but is run by the European Commission in this case. So you have delegations from each country in Europe. And again, it's working on the strategy for standardization. I don't want to go into any detail here, just to mention that the German strategy forum is working closely together and is basically mirroring the European forum. If you want to know more, there's a work stream on quantum led by Italy in this case. I just provided a link here that you can find more information. So I will give you a few examples from specific projects, but I would now like to focus a bit on Sensenelec and what we have been working on in the last, I think now it's about 6 or 7 years. And just to mention, there are of course also other European standardization organizations like ETSI we also work with, but I will not talk about this at all today, but focus on the national delegation principle Sensenelec. So the work on standardization with Sensenelec started basically in 2020, and back then it was not yet a committee, but it was rather a focus group. And the idea was really to figure out what are actually the needs for standardization in quantum technology, because that's, first of all, you need to know where you want to go actually before you can start your work. This took us something like 2 to 3 years, a lot of discussion with hundreds of European experts. You see the numbers here, so we had a lot of meetings. It was also during Corona, which was kind of fun because you don't get a chance to personally talk to the people. And it actually was extremely important to have, after COVID-19, the first meeting in person to get to consensus. So that was really instrumental. That's what I personally learned in this time. The result of all of this was that we came up with a roadmap that you can see here that gives structure and an idea how we can tackle standardization in quantum technology. Because, and we heard this already, it's quite a broad topic. You have different things that all belong together but are still separate. How to deal with that? And I don't really want to go into detail here. Again, if you want to know more about this, you can read it in the roadmap. It's publicly available. And basically, you can see this temple model where you have the different domains of quantum and also cross-cutting topics. And this is what we used then in 2023 to establish an actual standardization committee in Europe, which is called JTC 22. So this was in 2023, based on this 3 years work. And we heard about it before, that standardization, you cannot simply go out there and say, okay, this is a great standard, let's go and do it. You need a lot of consensus work. And just to say for Sensenelec, even before we started the Joint Technical Committee, we had 3 years of work on the roadmap. Okay, so in 2023, we then had the foundation of the committee. The people here that are the managing team are the same that also did run the focus group. So it's my colleague Oscar van Deventer from TNO from the Netherlands. It's myself, so we are the co-chairs of this committee. And the secretary is by Dean, so by Germany. And again, without going into details, I will show a few specific examples, but I think it's interesting to look at the structure and who is running the working groups. So this is basically derived from the roadmap. And we have one working group on strategy, the convener is myself, and then we have 3 technical working groups working on actual standardization. One is on quantum metrology, sensing and enhanced imaging and enabling technologies. It's led by UK. Then we have one on quantum computing simulation led by France, and another one on quantum communications and quantum cryptography led by Spain. And I think it's good and interesting to see that we have strong countries from Europe playing different convener roles in JTC 22, which is very important to get a consensus and also to work effectively. Okay, so with that, I would just like to show you 2 or 3 specific examples from Germany and from Europe, how we make sure that science-based standards and technical input actually leads into standardization. It has been said before, and I think it's extremely important for us as metrology institutes, but I also think it's in general very important that standards are science-based and we get a close connection to technical work. And I just want to show you a few projects, there are more, but a few how we do this in Germany and in Europe. So this is one project, I won't go into details at all. It's called Umbrella Project Quantum Communication in Germany. It's coordinated by PTB, and it brings together the supply chain in Germany. And if you look at this circle of partners, it's starting from fundamental research over applied research, industry consortia, and also networks, and it also includes standardization. In these projects, we also get funding for test beds and characterization measurements, and the results we get out of this project is fed into standardization via DEAN. So DEAN is basically subcontracted, so a direct partner in this project. So that's one way. So we get a connection from science and development into standardization. And via DEAN, of course, it goes to European and hopefully global standardization. It also goes the other way around, because I believe if you want early adoption of standardization in development and science, you need to explain how standardization works in science and in development. And this is also the role of DEAN here. So we also do workshops for the broader German, in this case, quantum communication community, to explain how people can actually be involved in standardization without too much effort. So that's also very important for us. And just one example how we try to develop this in the German ecosystem. Another example is on a European level. So we heard yesterday that there's a lot of funding and projects going on a European level. So this is from Euramet, which is the European Organization of Metrology Institutes, and there's a project that's called Aquantech. I won't go into the details again, but it's about single electron science in the end. There's a certain gap that needs to be addressed, and you can see that a lot of partners teamed up in the consortium, as you see in the lower part of the slide, to address this challenge. And as you can see, there's also partners from Korea and from Japan in this project, which is, I think, very good that we have this opportunity. The science that's done in this project is also, again, led to characterization and terminology understanding and development that, again, is fed by this consortium into standardization, for instance, in Sensenelix by colleagues of mine. Another project, just very briefly, on a European level is the so-called Q-Test consortium that you can see on the upper side there. This is several research and technology organizations, including metrology institutes from all over Europe, that form a consortium and offer test beds and characterization for industry. So this is, by design, an offer for industry. Industry can give components to this consortium free of charge and get a characterization and measurement of those devices. Examples include, for instance, ion traps. So this is what we did at PTB. It's also about entangled photon sources. It's about traveling wave parametric amplifiers for superconducting devices, and so on and so forth. And ideally, we also do this characterization at several different institutes so that we can be really sure that the characterization makes sense and use that to feed it again into standardization. And this is what I show here. So this is now, again, a new work item proposals from JTC22, Sensenelec, and directly from different projects, as for instance Q-Test, we got input together with other partners for new work item proposals. And I think this is really important to see that science work and technical work directly led into first metrology, characterization, terminology standardization, so to get a science-based standardization starting point. And topics, just as I mentioned, include exactly what I showed you: characterization for superconducting parametric amplifiers, ion trap characterization, and also others. It's also important to say that JTC22 has its first standardization deliverable just now that's formally went through all the process. That's called a layer model of quantum computing. That also goes back many years, actually, the work on that. Okay, that was about the point to make this connection between standardization and technical work, which I think is very fundamental and important from a European perspective. I would like to end to make this connection. I talked a lot about Europe mostly and a bit about what we do in Germany. This is only the start. So the idea is not to have standardization only in Europe. The idea is really to have a good starting point and consensus in Europe to continue to work on an international level. And it has been said before, I say it again, IEC ISO, and I guess I get the spelling right, IEC ISO JTC3 is very fundamental for that, so we are also happy to contribute there, and we hope that some of the ideas we developed in Europe and where we have first standards actually coming up, we can align and cooperate with ISO IEC on an international level. And I also just briefly want to mention that NMIQ, of course, is also another tool that's extremely helpful and important for us to align what we develop on a national and European level and to get experience from outside internationally to align. Okay, and then with the last 30 seconds, I would like to end with an invitation. So the next IEC general meeting is actually in Germany, in Hamburg in 2026. So save the date, it's 16th to 20th of November. And there's also a meeting of JTC3 in this general meeting. And it's co-organized by PTB, industry partners, DKE, and IEC. So if you are visiting JTC3, I guess you will be there, but also if you're interested in quantum ecosystem and what's going on, I would be very happy to see some of you in Hamburg in November. And with that, I thank you very much for your attention.
Thank you for great introduction. My name is Hwang Chul-han, Korean name, and my English nickname is Rod. And I really honored to be here to share the SK Telecom's experiences for the standardization. And today I will say something about quantum security and the upcoming service of wireless service, 6G. And okay, let's start. I think SK Telecom is a telco service provider in Korea, and we have a lot of work with many SDOs in the world, like NIST, 3GPP, but we are mainly work with 3GPP because we are a telco service provider. There's many standards like frequencies, spectrum bandwidth, and architectures, and essentially security also. I think there's many SDOs in this slide. You can see the NIST is published PQC algorithm. I remember 2 years ago. 3 documents is officially published. And what about key combiners or key derivation functions? This is very good rules for the security industry. And the 3GPP, they also considering about transition. How do we transition to the what about standalone PQC or hybrid PQC and existing modern cryptography to the new post-quantum cryptography. And the SE is really a tradition and a very good SDOs for the QKD and also PQC. I think they had published many documents for the QKD, like GS group studies, QKD 104, 105, 108, 120. And later slide, I will show what all 21 is main editor is from SK Telecom, Kim Min-young. And IETF is they're really good doing about IP networking, and they are also doing some in PQC standard document, mixing QKD keys, QKD or whatever, QKD PQC keys with their IPsec IKE version 2 protocol. There's many document is published. And you know that these 4 SDO is international groups, but and below that there's NIS and NSRs. There are announced in domestic. In Korea, there are quantum security requirement for the government sector, like a QENC and QKMS and QKD. And also, you know that NIST is 10 years ago, they doing PQC contests all over the world, and in Korea, KPQC contest is doing, and they announced they pick up the 4 KPQC candidates, Entru, Smagoti, AMO, and Hete, and they are ready for, I know, they ready for the published official document very soon. And TTA is very SDO for the many industrial phases like PQC for the transport network and the QKD testing, security for the hardware supply chains, and QKD post-processing, and the QKD requirement for the security requirement for the QKD. And this is the main topic for today's presentation is 3GPP standardization for the 6G. You know that I remember 2018, before 10 years ago, 5G service in Korea is launched world first, I remember. And maybe 10 years later, mainly we have 3 or 4 years remaining. We can see the next generation 6G wireless service. And 3GPP is announced their roadmap for the 3G, 6G road standard. They are targeting end of 2028. They want to finalize the standard document. And this is last month's 3GPP's announcement. They want to finalize the 3GPP 6G document standard December 2028. Maybe in telco industry, even numbers of service generation like 2G, 4G, maybe 6G, very successful rather than odd numbers of wireless service like 3G, 5G. I think then upcoming 6G is very innovative and very promising services I'm expecting. And 3GPP also prepare their new standards to fit their this very decisive and bold requirement, I think. And the 3GPP-TR 333 and 703, this is not the official technical specification. This is technical report, like a study. Officially, PQC is not adopting 5G's standard, not yet. They are studying, and in 3GPP, there are every such individual sectors, and they are trying to going to official. And in this document, they say 3GPP had to collaborate with the other SDOs like ITF, what about ETSI, NIST, and these standards is doing very well to other SDOs, not 3GPP, and they have to seeing or they have to liaison SDOs, each SDO work together and co-work. But 3GPP had to handle by themselves like these two factions minimally. Suki is subscriber identification, like a mobile phone number. Each of you have like a 101 or 301, like the MIN number is. But you know that in the security phases, if these plain text is coming on the wire, it is very problem in the security. Then 3GPP suggests we have to hiding subscriber ID like Suki. How hiding is encryption. Encryption, it can conceal subscriber ID for mobile phone numbers, and hackers cannot touch it, cannot following each subscriber's record or data. They can handle this. But you know that Suki encryption is by the modern cryptography like ECC, and you know that quantum computing is emerged, their security threat is very emerged, and we have to find some next generation encryption solution to this, hiding this subscriber ID. They propose we have to dealing with this modern cryptography like ECC to PQC. And one of the protocols is Maikisake. This is a protocol for the mission critical push to talk service, MCPTT, and it also has a security part for the keep the secure data, and we have to change this like ECC to the PQC. And this and there's some parts to be changed. We cannot use existing component, not the same. We have to change some part. This is a minimal proposed. We have to change UE, user equipment side, and this can using card. And the home network side is, this is managed by the telco service provider, like base stations or authentication centers. And this is, in 5G, there's a UDM, Unified Data Management. It is handling SUKI encryptions, mainly role of this node. And they propose we have to find out what is our best option for the hybrid algorithm or standalone. But you know that PQC is very safe, I think believed to safe, but it is newly announced and it is not long-term verified, and we have time for the trust. And they propose hybrid approaches, mixing two different algorithms, modern cryptography and the PQC. And it will be one of the options for the ECDH and MLKEM mixing together. And another thing, make two different keys, and how we combine these two different keys by one key, we need appropriate key combiner. 3GPP said for key combiner, we have to see the NIST standard. NIST announced this document last year, maybe last year, end of last year, I remember. This SP 800-227, it has a recommendation for the key KEM. KEM is a very common architecture for the deploying PQC. You know that RSA and DP-Hellman is commonly used key exchange for the share the key materials to endpoint and make their own keys. But in PQC, they commonly propose KEM architectures. It means at least make some key, private key and public keys, and at least give their public key to the Bob. This is a different but very efficient way to do encryption thing. And quantum safe, you know, the quantum safe, there's a classical cryptography, I mean ECC and RSA. It is very old and mature, and everyone loves it. But it has a long-term verified. But you know that if quantum computer is coming up, it can be cracked. Everyone very care about this, and they propose we have to go to another next generation cryptography, PQC. PQC is very new and safe. I already said that, believed to be safe, but it just born. It takes time to the trust. Then they propose mixing two different keys, to classical cryptography and PQC. This, we can call it hybrid approaches. And each cryptography algorithm is working their own processors, procedures, but making two different keys, we have mixing it very efficiently. And this NIST document proposed approved the key combiner. This already published, or what about key combining, or a key derivation or a key combination document already, SP 856C, SP 800-133. But in 227 new document, they said we have to find out there's a input of this key combiner is very important, or about shared secret, ciphertext, encapsulation keys, and domain separator. Because in SP 800-133, in this document, there's some key combination method like concatenation and XORs and key extraction, HKEM, HMAC key extraction. But in this new document, they propose input of key combiner is very, very important. And you have to, like key 1, K1, C1, EK1 is for the classical cryptography, and K2, C2, EK2 is for the PQC parameters. And I think this input is very important for this IND-CCA security, to fit for this level of security. And this is Etsy. Etsy is very good SDO for the QKD and PQC, and we are working a long time ago with Etsy. And this is a new standard project, GSQKD 021. It is orchestrating within KMS various QKD for the different KMS vendors and various QKD vendors. It is multi-vendor QKMS and QKD. Because we are telco service provider, we very important thought about multi-vendors. Not sole vendors is not good for our strategy for the procurement and supply chain management. And we considered about how we deal with the 2 different or 3 different vendors. And this all-21 standard is very good for our requirement. Main editor is from SK Telecom, Kim Min-young. Kim Min-young is main editor and good researcher. And I think we need soon, we need published a new draft of this standard, I think. And with this SQKD GS021, we work with IDQ and also new owner of this IDQ company, IonQ, and we co-work for the global quantum security standard. And I think this is okay. We'll go back to the 3GPP. And I think 3GPP said, they announced, they said they finalized this standard end of 2028. But you know that for the commercialization, we need more time to do make some smartphone systems. Then I think we can see the 6G service at least 2028 or 2030s. We can see the new, very next generation wireless service at that time, I'm expecting. And and now I can say that this document is just a study for the transitioning quantum cryptography in the wireless service, but we have to do more thing to go to specification for the official document. We only have 2 or 3 years, but for now, at this moment, I think it can go for the officially for the 3PP standard or not. Maybe next year we can see it. We can see it how we this PQC go to the on tracks or still studying, I think. Okay. How many times do I have? Oh, thank you. Thank you for having me, and thank you. Thank you.
Thank you very much for your introduction. So, Barbara is coming. So we are just in the 3-day journey to the quantum world. So our key word of our 3-day conference is how we can build up the quantum ecosystem. So Barbara, okay, welcome to join us. And Barbara just showed us a very well-designed presentation about the cycle of technology. Starting from the R&D, that is going to the final goal is industrialization. So this is the second day. It's a very timely, right? That is, we are just discussing that the standardization, because that the standard is a kind of the bridging element between R&D products to industrialization product. So I think it's your audience is just get some kind of information about how we can work for the standardization for some quantum technology industrialization. So we would like to share that is usually when this kind of a little advanced technology is to become something like industrialization, then we face to something like some technical hurdles. So probably the first our discussion point is in here. So how we can reduce this kind of technical hurdles or some kind of difficulties to just accelerate that QT industrialization. So probably our prominent speakers, why don't you share that your wisdom to your observation? So let's starting from the here. Your mic is your left hand. It's mine.
Yeah. So to accelerate the adoption of standards for the industry. So actually, I'm from KRISS, National Metrology Institute. I have already presented something we can do for this job. So actually, we are experts in measurement science and metrology, and also we are traceable to the SI units. And also our strength is to have a common framework among global NMIs. So in terms of this point, we can help industry to, if they have some difficulties in some areas, like, for example, in quantum. So quantum technology is a fast evolving technology field. And in this case, companies can often face uncertainties in terminology. What is this? And or sometimes they have difficulties in, find out what is a performance metric, what is the important metric for their product, or how they can measure for that metric, and so on. So in that case, KRISS is an expert because we have a long history of developing measurement science, and so we can service that company for the guidance, best practices, or we can evaluate their product. So in this way, we can reduce the uncertainty for them to reach to the market. Yeah.
Okay. Thank you, Derek. He just point out that some importance of standardization on the terminology. Then Barbara?
Yeah, thank you. So being from a metrology institute like Dai-Hyuk, we like to gloat that we got into quantum first, or at least very early on. And we did that because we needed to do that to make better measurements. And so when you talk about how can we in general help overcome the hurdles to adoption, et cetera, part of that is that metrology institutes like KRISS and NIST, et cetera, should continue to do the great science that we do, because a lot of that great science underpins the great technology that we're seeing come out in the market today. So one thing we can do is just keep doing what we do best, right? And knowing that a lot of the technology we're developing for metrology is going to turn into the underpinnings for new technologies as well. So that, and I think Dai-Hyuk was talking about just providing services and characterization. And then another, part of the reason that we stood up NMIQ to begin with was because we know that there's a lot of things industry needs in order to keep moving quickly, and they can't wait for a standard to be developed. And they may never need a standard to be developed, but there may be incremental measurements that we can either create a good technique for them or just make them aware that we already know how to do it.
Yes.
So those are things we can do to help.
Okay, thank you very much. I think Barbara is also pointing out that one of the key elements of a standard is measurement. So I would like to express our appreciation that of the leadership of NIST to find out that the new methodology and also some characterization method. So thank you. Then Cyrus, you just your title of your presentation is really refreshing. Something like the past, present, and the innovation, maybe future, right? So we are just looking for some kind of innovation of a technology from the quantum, based on quantum technology. So based on your experience, please tell us, what do you learn from the past? Then what kind of the wisdom to you just use for some kind of quantum industrialization?
Thank you very much. So we've learned that having industry at the heart of our national program at NPL is absolutely imperative, because it's no good just to say to a company, we're going to benchmark and verify your technology and then leave it at that. So ultimately, if the answers aren't what the companies want to hear, it's our job as an NMI to help them scale their technology, and it's our program's job to help them take their technologies effectively to market. So we help them with technical guidance to improve performance, accuracy, or resolution. And the best examples of that we can give are a couple. So I mentioned in the presentation, going forward, as part of the Procure program, that benchmarking and standards will be at the heart of decision-making in the UK, based on procurements for quantum computers, and based on the work that we're doing with the NQCC. But it's not just in computing. We're building test beds on quantum networks for people to come and test and verify their single photon detectors, or even in the PNT side of things, so position, navigation, and timing, we're thinking about things like setting up test beds for magnetometers, atomic spin gyros, and the like. But probably most prevalent is the work we do on clocks. So in the UK, we basically work with every major clock company, probably globally, to be honest. I would say we work with US companies, Australian companies, and hopefully one day, Korean companies, to test and verify their clocks, and then, look at their stability and help sort of derive better performance so they can get their technologies to market. So thank you.
Thank you, Cyrus. And so, wisdom from PTB, from Germany, Nicolas. Could you share the viewpoint? What is the kind of key challenge to the quantum technology industrialization?
Of course, yes. Thank you very much, Haesong. Well, I'm also from a National Metrology Institute, and I would maybe add to what we heard already two things. And I agree that industry participation is key, so that has to be in the center of it all. But we are in an early stage, and as you saw in my talk, PTB is taking a is taking a lead in standardization now. And the idea is really to set the stage until it's taken over by industry in some sense. So we try to help to set the stage, to create structures, so that in the future there is a structure in place that can be used by an upcoming market. So that is one thing I would like to add. Another aspect I would like to add is that in some of the quantum technologies, we need independent test and measurement to make decisions. That's true, I totally agree, but I think it sometimes even goes further than that. For instance, for quantum key distribution, you need measurements that can be traced back to national normals before that can be even a market. And that is the role of a National Metrology Institute, and it is, and at this point we only have the first standards for that. We're not done by that, and the measurements are also in early stage. So I think this is also another important point. Before you can even have a market, I mean, go to a bank and sell them something where you claim it has certain properties, but you cannot trace that back to a national standard. That won't work. So that's another point I would like to state. And the third point, if I may, I think another thing, Barbara said it, right, that National Metrology Institutes have a basically decade-long or even century-long history in quantum physics, let's say, not in technology, but in physics. And I think we can also play a role in technology transfer. And just to mention one example from us, from PTB, we, together with industry consortia, we developed a so-called new optical atomic clock that was commercialized last year from a German company, which is like one of the first optical atomic clocks that you can buy, which is a factor of 10 better than anything that is on the market right now. And I think there are more, as Cyrus said, there are many other examples from a technology perspective, and I think this is another aspect. That's not standardization, but I think it plays into that, supporting quantum ecosystem.
Thank you very much. And probably naturally we are just focused on something like an exemplary case, how we overcome some kind of a technology threshold that is in terms of the telecommunication technology. There is just a phase to the something how that quantum technology will be applied to. So, Dr. Huang, that just share your experience, how you can overcome some kind of technical difficulties, especially in industrialization of a quantum, the telecommunication industry.
Yes, thank you, 예성 교수님. I think standard is a very essential key for the motivating quantum security in the telco system, telco industry also. I think, and we doing some great job with many SDOs like NIST, ETSI, ITF, and these are our today's presenters doing very good work to make better standardization. I think standards is make some good ecosystem in Korea also. I think you can see that in these floors there's many small and business companies. Compared with what about 4 or 5 years ago, first we doing Quantum Korea exhibition for the first time. There's many companies arise, and I think if we are motivating that company, we have to make good standards and roadmaps, and I think very nice technique. And also, I think there's some, what about certification is very good, because it is not what about performance comparison. Security is a very different point of view. It has to be secure, most of them. If some person propose new security, but if it can break within 1 day, it is useless, I think. Certification is very, very good, I think. And, but it takes a time to get the proper certification. It needs a time, not a day. It can take more than years or months. I think standards and certification is a very key driver for the quantum security, I think. Thank you.
Thank you very much. Then now that we are just invite some 3 NMIs, the most important NMIs in the world, that to share that some kind of just the standardization, the standard point of view. We are just discussing about some kind of measurement. Then how just to share your experience that we just solve some kind of in-field problems or some kind of overcome from the requested from industry people. So who will be the start? Barbara or Cyrus? Barbara?
Sure, I can talk a little about single photon detector characterization. So single photon detectors are a key enabling technology in many quantum technologies, computing, sensing, et cetera, networking, of course. And there is a fledgling industry now providing products into this market. And they would like to come to our institutes like other companies do in more mature technologies and know they can get a trusted measurement. So I think many of us are setting up capabilities in this area. And of course, we have many collaborations together. I'm also looking at my colleague Kevin Thompson with NRC, because NIST and NRC also have a rich tradition of collaborating in this space. But I think it's quite challenging because the technologies, just like so many things in quantum, the technologies are still evolving. Every test is a one-off, right? And so while we have a detector measurement characterization program and we are standing it up like a standard service, the truth is it's so far from standard. So when it's more like each item is an individual collaboration. And so I think we have the challenge in that area, and we're going to see that more and more. And so one way, a couple of approaches. One is, of course, we're pursuing that as a service. It will, over time, become more efficient and quicker and less one-off. But another approach that I think many of us are taking are partnering with external organizations to provide those services, because our staff time is precious. We are not, we're government agencies. So NIST, for example, is partnering with a consortium called Elevate Quantum in the Boulder region. And they're looking to stand up a cryogenic component testing service and partnering with us to glean the expertise and know-how as to how to make those measurements, but they won't be done at NIST. So I think we're all looking at creative ways to get the job done.
Yeah, Barbara just reminded me that it's something like a purity of a photon source or detector. It's a kind of big contribution from NIST. Isn't it? Even 2022, it's a Nobel laureate, Professor Zeiling, just also emphasized that kind of contribution, right? Yeah.
And just to camp onto that, I'd like to give a shout out to our late colleague, Dr. Se-Woo Nam, who received a very prestigious award here in Korea, the Hoam Award, a couple of years ago. He was foundational in setting up our detector program.
Yeah. So in case of a photon source, it's a really important tool not only for quantum computer or just quantum communication. So Cyrus, could you share that your experience in APL, then something like a synchronization of some kind of a optical signal or for some kind of a telecommunication area? So.
Sure. I mean, it has to be said, thank you very much for calling us the best 3 NMIs in the world. We were at KRISS, exactly, we were at KRISS on Tuesday, and you guys are actually building, you know, some superconducting qubit proper computing capability, which was incredibly impressive, which we're not, well, certainly NPL are not doing. I think it's fair to say that because this is a really expensive business and the capital costs of setting up equipment is so difficult, that it is a collaborative sort of endeavor. So I look at an example, and we'll get onto the optical link in a minute, but we look at an example of things like post-quantum cryptography. I acknowledge, as someone that's leading the program in the UK in our lab, we've left it late. So we are not really at the moment in the position that we should be as a National Metrology Institute in an endeavor like PQC. We're very lucky to be able to work with NIST and learn from NIST in that respect. But because PQC is such a mathematical sort of concept, we're now looking at effectively developing capability in that area. So it just shows that not even the best NMIs, as you called it, not us or me, can always get it right. In terms of the optical sort of side of things, what we're doing in the UK is we're setting up a distributed sort of network, so like a quantum network, mimicking a lot some of the work we're doing on our National Timing Center activities. So whilst not entirely quantum, what we're doing in the NTC area is effectively setting up a distributed timing network around the country. And effectively, along with the IQN hub, which is the major sort of group in the UK looking at things like QKD distribution and quantum networking, we're doing a very similar thing. But we're working with the likes of BT, so who are a major telecommunications company in the UK, and Vodafone. And actually, what's really interesting about the UK, and where we're very fortunate, is whilst we don't always have the strongest fabrication capability, so, you know, we can't build stuff at mass scale like you guys can do in Korea, what we do have is some very interesting niche R&D capabilities within really big organizations like British Telecom and Vodafone that we can work with and utilize. And actually, they're going to be a key part of the future activities in our quantum networking sort of testbed area. So what the UK is really looking to do is use its NMI to drive the standards, but not alone, working very much hand in hand with industry. The other area that I just want to sort of comment on really briefly is around, as I said, clocks earlier. We've realized that it's no good just to tell a company, as I said earlier, that the clock that they're making is not good enough. That they need help, they need our support to get it to market. Money is very, very tight, so we should be working with each other to share learnings, not just in computing, but across the quantum ecosystem on, you know, making the best sort of capabilities and technologies for the right application. And it has to be said, you don't always need a clock with 10 to the minus whatever accuracy. Sometimes, you know, we use a term in the UK called horses for courses, which may not be familiar to a lot of people in the room, but it's effectively making sure that the technology that you're using is for the right application. And you can only do that by working very closely with industry. Thank you.
Okay, thank you, Cyrus. And also, Nicolas?
Yeah, well, I'm always the third in line, so I have to think of things to add. But yes, I can certainly do that. Maybe I agree with most of what has been said, but to add to this, you know, numbers of technologies, quantum magnetometers, I think, is another topic that's quite interesting, and it's also one of the technologies that's quite mature, which I think is very good. And just to mention, at PTB we have a facility that's a relatively big magnetically shielded room in Berlin where people can come in and reference their magnetometers against so-called squid magnetometers that we built ourselves since decades, basically. And that's just another example where we can provide independent measurement infrastructure for companies that nowadays build optically pumped magnetometers or NV center magnetometers that give you new possibilities. But also those have to be characterized compared to existing technologies And it's also non-trivial to understand what you would actually measure in those. So it's you can just replace the technology. And also there, we need to understand what terminology we use, what parameters to measure. And indeed, that's one of the working groups also in NMIQ exactly for that reason. Because there are component and products out in the market. We have discussions about this, but it's far from clear. If you buy a product, you look at the data sheet, what you get at this point. So, and I think that's one of the examples. I guess I leave it at that to leave some more space and time.
Well, we are not some kind of intentionally organized, but our dialogue is very naturally flowed. Okay, the next agenda is something like NMIQ issues, something how we can internationally harmonize.
Can I say something? Because KRISS is also one of the best NMIs.
No. We are host countries.
So, but I want to share.
Yes.
So I want to emphasize one thing that. We are developing superconducting quantum computer, as I already presented. That already 20 qubit has demonstrated, and then 300 qubit logical qubit quantum error corrected. So by 2032. So as far as I know, this superconducting quantum computer, the only NMI I think that in the world who developed the superconducting quantum computer. This is because Korea is a kind of a late starter in quantum technology. So that's why the government invest money to the KRISS, because we have expertise in quantum technology. So, but we believe that this is very important for us because we will share these benefits. For example, nowadays I heard that the big company like Samsung and LG is considering to join to the computing system development. So our knowledge can transfer to the Korean company.
Yeah, that's right.
And then next one is that we can use our system for the test bed. So by test bed, I mean that we have some enabling technology companies like a refrigerator developer or a cable or some amplifier. And so they all need, they are all needed to develop superconducting quantum computer. So that components can be tested at KRISS by using our system. So in this way, we can also have the enabling industries to have our own technology assets. Yeah, thank you.
Yeah, actually, the KRISS just contribute a lot of measurement technology, especially in the nanotechnology into the semiconductor industry, something like depth profiling, and also can be, visualize that the 2 nano technology, currently Samsung or the Hynix did it. So you know that, I appreciate that. So probably the Kevin is a kind of very frustrating because Kevin is also the representative of Canadian NMI. So why don't you, I would like to invite you. So please just kind of a friendship under the JTC3. So say something about maybe also Kevin will be also one of the important speaker in the afternoon session that I make the TC25.
Okay. Thank you for that, though a little prep might have been nice. So I think one of the, I agree with what the panel and yourself has been saying, that National Metrology Institutes are in a unique position here to really help and work with industry, but we don't actually know the exact formula for that. So this is an iterative process. This is a learning process. We're trying to figure out where to make the most impact. We have some ideas. We're trying them, but some of them are going to be wrong. And so we need to hear back where we are helping and where it's actually not so much. As one of the panelists mentioned, there are limited resources. I mean, this is a good time to be in quantum, but we need to be effective with those precious investments which are being made. So we look forward to engaging with all of our industries and also working together collaboratively, because together we can go much further. So thank you.
Okay, thank you very much, Kevin. Yeah. So let's move to the next items we are just think about. So now we just get some information how that something like a measurement or some kind of a very high level characterization tool is just to solve some problem, especially from the industry people. Then the next one is something like how we can harmonize that kind of something that the individual tools developed by each NMI. So maybe one of the answers is NMIQ. So I think it's Barbara just mentioned that NMIQ, but also we have a co-chair of NMIQ in the floor. So I would like to invite team to probably just announce, say that something about NMIQ. So sorry about this. This area is something limited, so we cannot invite all of you. So.
No, it's fine. I think one of the things that's really key to this is this job is too big for all of us to do individually, so we have to come together. And like-minded countries, we know lots of the answers. We just don't know how to get that information out efficiently to help people. And so NMIQ is about doing that. By working together, we can get the confidence in the things we're providing for industry, but we can do it in a much quicker way. And it's a real challenge to us as Metrology Institute, because we like to measure things, and then we like to measure it 1,000 more times, and then we ask our friends to measure it 1,000 times, and their friends, etc. 5 years later, we might have a very good answer. That's just not good enough at the moment. We're in a global world where everybody knows everything. So we have to be quicker if we're going to be useful. And I think through NMIQ, that's a very good way of doing things. We've been talking with KRISS, and we're hoping KRISS will become part of that soon. And I think they'll add another dimension, because KRISS has got some amazing capability. So I think we just next time just say in the top 10 NMIs, and we can include quite a few others. So.
Okay, thank you, team. Actually, that something we just carry out some standardization activity. How we can obtain something like reliability and representability. So that how we can acquire that RNR. So in that point, as in a kind of a quantum technology quite far advanced, then the existence of NMIQ is a really big contribution, a kind of a very highly support to our JTC3 activities. So, but I mean, one of my main missions is how we can harmonize our P member countries with the NMIQ. So we'll just the kind of discussion will be continued in an afternoon session again. That the venue is the second floor of DDP Plaza, the design. That okay. So I would like to encourage all of you to also attend that technical sessions. Okay. Let's move to the next one. That is the. So now that something like how we can get some kind of a global standardization. So how we can make a global harmonization. That is a kind of our big issues. That is going to some kind of how we can combine with some kind of industry people, so etc. So I would like to invite that first from the Dr. Huang is the only one, the expert in the floor from the industry. So could you just share that your, opinion on that?
Yes, thank you. I think this is a very prominent or about things for the promoting and motivating this quantum technology to the industry. I think you know that we are a telco service provider, and we focus on the what about networking technologies combining to our wireless service, like 5G, 6Gs, rather than algorithm. We are okay. We are also interested with algorithm, but we need to technology to get that make our services better. Then I think we need our ecosystem is very important. I think. And SK Telecom, as a telco service provider, we can make some bridge to between the industries, companies, private companies, and between SDOs, many NMIs, standardization organization. I think we can do that roles than any other person. I think we are very actively working many SDOs and companies, and also it is very good for our supply chain. For the many our ecosystem is bigger and bigger. It is good for us, I think, and to make there's some problem to the making this industry more big and make some more monies to this from this quantum security. I think we have to make some more robustness of our ecosystem of the quantum security. Thank you.
Okay, thank you very much. Then I would like to ask Nicolas, because he is the also representative of JTC 22, just 1 year ahead of JTC 3 from the European side. So usually that maybe you have a very deep discussion on that, try to solve some kind of that kind of issues. So could you share that your experience there? Yeah. How we can harmonize some kind of SDOs? Yeah.
Okay, yes, of course. I mean, I showed it in my talk a bit. It took us a very long time to get, I wouldn't even say consensus, but it's about people, to get some common agreement of what we are actually working on in JTC 22. And this is in quotation only Europe, right? And I think in JTC 3, this is to some part maybe behind us, but also ahead of us. And I think that's from my point of view the challenge for the committee. So as I showed you, it took us 3 years to come up with a roadmap. But I have to say, after then, after we had that and we had this common agreement what we are working on and how we work on it, it also took off a bit, right? Now we have a lot of new work item proposals, and then it worked out pretty well. And I think that's, from my personal experience, that's how we should do it also in other committees and also in JTC3 from my personal experience. So I think that would be a way to go. I would also like to add, and thanks Kevin for mentioning that there's also a certain risk, right? Because we are early on, and what we see in standardization in JTC 22 and also on a national level is that industry is taking part in this, but sometimes is also in more like a waiting, observing position, to be honest, right? And we have to be honest about that quantum is early on, and stuff we do might not be exactly right. And I think it's totally okay to start this now, but we have also to acknowledge that we might need to adapt a bit, also in standardization.
Yeah.
And I think it's very important to state that. So those would be the main two takeaways. And when we talk to industry partners, that's also why we always say, if you develop a standard, it's not set in stone, right? It should be revisited after, at least I think in Germany it's 5 years or 3 years. If it's still state of the art, the criteria are shown, if it's still reflecting what industry needs. So even if you come up with a standard that's not exactly right, probably you can work with that. So this would be my main takeaway.
Yes. I think it's for the Korean audience that a little bit something I would like to add some explanation about the SDOs. Probably you may just find out many SDOs related to only actually telecommunication area, but also the other SDOs, IEEE or etc. But the JTC3, JTC is a joint technical committee, both agreed by ISO and IEC. So usually the ISO side is something like a software-related standard, and IEC side is related to the hardware side. So first the JTC is a JTC1, that is information technology, that is in 1987. So ours is actually second technical committee, but there is no JTC2. Actually, JPC2. So JPC is a joint project committee that is disbanded in 2016 to publish that one international standard about the energy efficiency. So the JTC3 is the second joint technical committee as from something like 40 years after JTC1. So that is accelerating. Currently, the joint technical committee is 4 joint technical committee. JTC4 is a smart city, and JTC5 is a DPP, that is a digital product passport. Then actually that is ISO and IEC is very 2 columns. So they are just shared 2 by 2. So in case of JTC1, it's ISO, IEC, JTC1. Ours is led by IEC sub-directives, so IEC, ISO, JTC3. Then again, the JTC4 is a smart city. It's led by France. Then it's ISO, IEC, JTC4. Then go back to DPP issues. It's IEC, ISO, JTC5. That is led by Germany, it's the secretariat. And each technical committee is 2 leadership, chair and secretary. Actually, secretary is more important. Actually, secretariat country of JTC3 is UK. So for your reference, I would like a little bit explanation about this. And also, Barbara just mentioned that something ISO, IEC, JTC3 is, she said, oops. So there is a little delicate issues, something like this. Okay, so now you have something like 10 minutes left. So our something like the panel discussion, that is something like going to that way. We are just aiming to the ecosystem of quantum technology. That is how it means that how we can turn over from the R&D product to industrial product. Then between the 2 areas, standardization exists. So we are just working together, way that how we can set up the standards by some different SDO, and how we can get some kind of a global harmonization from each standards. So that is the role of JTC3. So now that probably the next day we just find out more some visualization of quantum technologies in a kind of exhibition, etc. So now I would like to ask all of our audience to if you have any comments or questions about today's discussion, then welcome to join us. Any questions, comments? Yes, Tim.
So if you had to choose just one parameter to standardize across any quantum technologies, quick answer from all the panels.
Terminology. I think it's one of the part in case of terminology is a contribution from NIST. It's a terminology of quantum photonics, right?
Yeah.
Just share some information. Yeah.
Oh, so I guess you think I should answer terminology. So it's funny. I was with another panel where the question was, what's your favorite atom? So, then people were voting, right? Which atom they like the best. Mm-hmm. So, yeah, very hard to pick one parameter, but for some reason what's popping to my mind is cryogenics. That there's maybe it's because I think there's so much low-hanging fruit there. And I think what's interesting in the quantum space is that things like cryogenics were developed for completely other industries. So there are standards out there that govern it, but they're completely optimized for things that are not important to us. I mean, like vacuum standards, et cetera, that don't have anything to do with the needs in the cryogenic community. So, and I think the same is true for like diamonds and NV centers. Mm-hmm. There are standards in that space and an industry in that space optimized for jewelry, not optimized for, you know, cutting edge quantum sensing. Yeah. So I think, I don't have a single answer for you, but I think somehow scooping up, right, those industries and making them relevant, more relevant, right, to what the quantum industry needs is, you know, interesting.
Actually, some kind of overview of our JTC3 activities. And, currently, I just faced to some kind of three main agenda. The one is the terminology. Currently, we are just developed the terminology on the standardization on terminology related to quantum technology. So three groups. One of the led by John Devani, the NPL, that is terminology related to metrics. So the second one is recently we just established a working group 15 that is a terminology related to a quantum computer. Then the other one is third group is a project team. I just forgot the number because of 5 digits. That is a limit of my brain. So the PT project team is led by Joshua Bianpen. Yeah, just Bianpen. Then it's a terminology on the quantum, something like that, sensors and also photonics included. So probably my mission is how we can harmonize that some product from the different three groups. The remaining two is something like NMIQ, how we can harmonize the NMI between NMIQ and our JTC3 activities. Yeah. So this is something also probably the working with Barbara, the Barbara's leadership, that how we can develop the SRL to just make something like, how I can say, very effective, some standardization roadmap for industry people. So that is something, yeah. So, are you happy with our answers?
I was just going to add to it. So, I mean, the concept that Barbara's been leading on in sort of understanding of where the technologies sit within a roadmap has been very, very effective. And so we've all been adopting that. But the question I get asked the most is, can you define a logical qubit? And I was hoping one of you would try to take that on and then get tied up, but
that's right.
We'll move to another question.
Yeah. Actually, it's in kind of a terminology on qubit. There are a lot of also terminologies, something like physical qubit or etc. So, anyhow, yes, Kevin, you just yeah.
Sure. Nicholas, you were talking about the role of government or institutions in trying to set up the right path and then for industry to come in. And so in the context of organizations like JTC3, do we have the right amount of industry engagement, or what's the role of government now? When do you want to hand it off? How do we navigate that?
Yeah, thanks, Kevin. It's a great question. I would say not yet, because we do see participation on the German level and so on and so forth on the international level. But at this point, I think I personally would like to see much more industry participation, also industry taking the lead in this, which is not happening yet. By the way, that's also something our government wants to see in the long run. And if you ask what happens, how do we manage that? I mean, we will keep it up. and see if it grows the industry participation. If it doesn't, at some point, probably our management will say, okay, what are you playing there in standardization bodies for 10 years if nothing happens, right? I guess I don't think this will happen if I look at Quantum Korea and other places, and that there is industry taking part in it strongly, but to be honest, it's still early on, and it is an investment that we do right now, and we need to see a return. Even though we are not a company, we need to see a return in engagement of industry. So that would be my take on it.
Actually, so my personal opinion on the terminology is actually it should be led by the English-speaking country. So maybe some UK and Canada or the United States is really feel some kind of some responsibility on that, because that in the field of nanotechnologies, we are just arguing that there's graphene-related materials or graphene-based materials for almost 7 years. Finally, our non-English speaking expert realized that is the difference between graphene-related and graphene-based. So at that time, actually the UK won. So yes, Kevin.
In
yes.
defense of non-native English-speaking colleagues, I'll say that I usually get the best feedback on papers from non-English speaking
really?
and so don't give an English paper to a German colleague unless you're ready to be humbled by their grasp of English.
Yeah, actually that's the reason why we are just come together, just to share that our experience. There is a kind of a collective intelligence, right? So we are just aiming to that. Then actually it's probably the Dayak will hate me that is ask him some kind of a little the closing remark as one of the host institute. Do you want to say some?
Yeah. Already time is over, so yeah, thank you for visiting us and also present your valuable history and future insights. So I hope this opportunity can increase awareness inside Korea for the importance of standardization. Thank you very much.
Okay, thank you very much. Thank you very much, all of you. Okay, thank you. Yeah.